Good morning, everyone. Now let's solve internal 1 paper, internal 1 section A. Myself, Zishan Khan, MTech IT 5th SEM, roll number 68. So we are solving data science internal 1 paper. Let's start with first question, which reads as give three commonly used statistical measures to characterize dispersion in complaint derived scores. Example, alleged offense severity, evidence strength, harm impact index. Discuss how these measures can be computed efficiently over large complaint repositories. Example, partition store, streaming aggregation, approximate sketches. So, three statistical measures of dispersion. Number one is standard deviation and variance. What it measures, what it actually measures. So, how far complaint scores, severity, evidence strength, harm index spread from the mean. The formula for it is 1 by n summation from I equal to 1 to n x of I, and variance is 1 by n summation of I equal to 1 to n xi minus u ka whole square. Standard deviation is sigma, standard deviation sigma, which is equal to root of sigma square. Why we use it? Number one, useful when data is roughly symmetric. Number two, shows overall variability around the average. Number three, sensitive to all values, so it captures even small changes in complaints. Now moving to next measures, that is in interquartile range, also represented as IQR. What it measures? So it is spread of the middle 50% of squares. It is speed of the middle 50% of scores. IQ are equal to Q3 minus Q1, where Q1 is the 25th percentile, Q3 is the 75th percentile. Why we use it? Number one, not affected by extreme values. Number two, good for skewed complaint data. Example, some complaints extremely severe. Number third, shows central spread more reliably than standard deviation when outliers exist. Number three measures is median absolute deviation, also represented as MAD. What it measures? Typically, the deviation from the mean. MAD equal to median into xi minus median of x. Why we use it? Number one, very robust to outliers. Good when complaint scores have sudden jumps or heavy tail distributions, often preferred over standard deviation for noisy or irregular complaint data. Now moving to question number two, which reads that sorted evidence strength score 1 to 100 extracted from complaint text, and the data is given for sorted values. A read as what is mean square, what is the median. So the mean and median. Mean is equal to sum, that is 788, 789, and number of terms is 26. So the mean will be 789 divided by 26, which is approximately equal to 30.35. Now median, since even an average of 13 and 14, the number of entries is even, so we calculate the mean of 13th and 14th values. For that we have to first arrange it in ascending order. So the 30th value is 25, 40th value is 30, so median will be 25 plus 30 divided by 2, which is 27.5. Now moving to B part, which read as what is are the modes. Comment on modality uni by trimodal. So variance and standard deviation using sample variance with x equal to 30.35 sum of square deviation. Now we first calculate the standard deviation, because we know that mode is the most repeating value. So the whatever be the most repeating value, that will be the mode. Now standard deviation will be squared of deviation, sum of squared of deviation, which will be equal to 4251.89 divided by 25, which is approximately equal to 170.1. Now s is 13, because root of 170.1 is 13. Now the answer of variance. Variance is, we know that is the under root of standard deviation, which is 170, and standard deviation is 13. Mid-range and quartile mid-range. For that we have formula mean plus max divided by 2. So here mean is 13 and max is 70, which will divide by 2 will give you 41.5. Now quartile is using median of halves. So lower 13 values is 7th value 21 to Q1 is equal to 21, and upper value 13 values, median 7th value 35 to Q3 is 35. Now 5 number summary. Minimum is 13, quantile 1 is 21, median equal to 27.5, and quartile 3 is 35. So maximum will be 70. Now we draw the box plot. Box plot of evidence strength score. Now the x column measures score. We draw a scale from 10 to 70. Draw a box from 21 to 35. Draw a line inside the box at 27.5 median. This red line will represent the median and draw whiskers from 13 to 70. Now 70 may be commented as a possible high square value. G part, plot versus quantile plot. So quantile plot, it acts as it is ordered component. At y-axis it is quantile scores of the data itself. It shows a distribution shape, skewness or spread. Now QQ, quantile plot, is compared to distribution. X-axis theoretical quantiles, example normal target DSS model. Y-axis data quantiles evidence scores. If points lie near a straight line, it gives data roughly follows the target distribution. Useful to check DSS assumption about evidence strength distribution. Now moving to third question, which reads as approximate median from group data. So severity range is given, frequency is given, and we have to calculate its median. So total n is equal to 3194. Median position will be n by 2. That is 1597th case. Cumulative frequency is given 200, 650, 950. 2450. Median class around 21 to 50 because 950 is less than 1599 and it is less than 2450. Use grouped median formula, and that is median equal to L plus N by 2 minus cumulative frequency divided by frequency into H, where L equal to 21 lower boundary, cumulative frequency 957, cumulative frequency before median class, F is stands for frequency width, that is 1500, and H is equal to 30 class width. So we are putting the values in the formula, that is L plus N by 2 minus CF divided by F into H. Now we putting the values 21 plus 5, 1597 minus 950 divided by 1500 into 30, which gives us approximately around 33.9. So the approx median severity will be around 34. Now the fourth question reads as a discrete intact sample records complaint age and self-assessed incidence impact percentage for 18 companies. We have to the data is given to us, and it is here we have to compute mean, median, standard deviation for age and impact percentage. So start with the mean. So we know that mean is sum of edges divided by number of edges. So sum of edges is 826 and number of edges is 18, which will be around 45.9 years. And the median is, since the data is even, so we take the average of the ninth and 10th value. Ninth value is 15, 10th value is 52. So the median will be 51 because 50 plus 50 plus 52 divided by 2 will give you 51. Now sample variance and standard deviation. Standard deviation will be 189 and the variance will be 13.7 years. Now moving to B part, impact mean, median, standard deviation. So sum of impact percentage will be 518.1. X impact will be around 5181.8.1 divided by 18, which will give you 28.8 percentage. Now sort and take middle, ninth and 10th value. So median impact will be 30.2 plus 31.2 divided by 2, which will be around 30.7 percentage. And the sample variance and standard deviation will be 85.6 and the impact will be 9.3 percentage. Now moving to box plot, age and impact. Age box plot. So minimum value here is 23 and quartile 1 will be 29, median is 51, quartile 3 will be 57 and maximum will go to 61. Now box from 29 to 57, line will be at 51, whisker will be at 23 and 61. As you see in the globe, the data which is given, according to it we had draw both the box plot of edges and box plots of impact in percentage. Now the C part read as scatter plot and Q plot. A scatter plot, at y-axis we take the age, at x-axis we take the age, and at y-axis we will take its impact percentage. Each point equal to one complaint, and visual check. Older complaints tend to show slightly higher impact scores, mild positive trend. QQ plot. Now we will plot the QQ plot. Before had we had draw, that is the box plot. Now QQ plot. So used to check if impact percentage, that is age, follows a normal distribution. Plot order data values versus theoretical normal quantiles. If point line near a line, so distribution will be approximately will be equal to normal, and helps decide if normal based statistical tests are valid. So the scatter plot, as you saw, it is a plot between age versus impact percentage. At y-axis we had taken the impact percentage and at x-axis we had taken the age. So this star will represent the data value which we had given. Thank you. Hope you have understood it very well. Have a good day.